Hello and welcome back to the Building HVAC Science podcast. If after listening you like what you heard today and you've not subscribed to the podcast, please consider doing so by typing Building HVAC Science into the search bar of your favorite podcast app, or even ask Alexa. You can now leave a voicemail by going to our podcast page, which is buildinghvacscience.com. Clicking on the microphone in the lower right-hand corner, you can leave a message there. We also encourage comments and feedbacks, no matter what platform you are enjoying our content. In today's episode, Eric interviews Keith Gifford, who is Senior Global Product Manager at Penn Controls. They have an in-depth discussion about the emerging use of A2L refrigerants in the HVACR industry. They're a new class of refrigerants. They discuss all the technical details, those aspects there. But Keith shares with us his unique perspective, shaped by extensive experience across all major refrigeration components. He explains the challenges, opportunities, and safety considerations surrounding A2Ls. They talk about the design and engineering hurdles posed by A2Ls and such things as material compatibility, flammability, mitigation, and the development of leak sensors calibrated to specific refrigerants. Keith also addresses the impact on service techs, building codes, system designs, and the importance of industry-wide education to ensure safe and effective adoption. Let's give you a chance to listen to Eric interviewing Keith Gifford, talking about from safety to sustainability, navigating the A2L revolution.
Hello, everyone. Welcome back to the Building HVAC Science podcast. Eric Kaiser here. Bill Spohn, missing in action again today. Anyways, we've got a special guest with us today, and we're going to talk with Mr. Keith Gifford, and he is the Senior Global Product Manager at Penn Controls. And we're going to talk about A2L topics today, which is a hot topic in the HVAC industry. There's been a lot of information out there about it, and we got a chance to bring Keith on and talk about this. So, Keith, welcome to the show.
Yeah, thank you.
Let's dig in here and get to know you a little bit better. We talked a little bit before the show, and it sounds like you've done some interesting things in your career. So tell us a little bit more.
I'm probably one of the few product managers in the industry that's had an opportunity to not only work for a controls manufacturer, but also to work for a manufacturer of refrigerant flow devices and a manufacturer of heat exchangers, and lastly, a manufacturer of compressors. So it completes the entire refrigeration cycle. And not only residential air conditioning, but also commercial air conditioning and, of course, commercial refrigeration. So fortunate to have been around a lot of great people that have a lot more knowledge than I do, but certainly have been a sponge to learn as much as I can along the way.
That's great. I love being around smarter people than I am because I always learn something from them. You got a wide variety of experience there. So you should, I'm guessing, have a pretty good understanding of what it takes to bring a new refrigerant in and then design controls and design components around that refrigerant to make sure everything's going to perform well in the field once it gets deployed.
As we were talking earlier, it's not as easy as just publishing some specifications for cooling capacity and efficiency and everything in between, but material compatibility is a big concern as well. As you have different chemical compounds, how is that going to affect motor windings? Is anything in the refrigeration system going to break down and cause problems with some of the smaller orifices, capillary tubes, distribution tubes, and so forth? In the past, there has been some issues with refrigerant changes associated with that. So manufacturers have learned, and really the devil's in the details to make sure that we're testing and comparing all of those things that I mentioned earlier.
And that takes a lot of time, I'm guessing, to go through all that stuff and really get it right. How long, time frame wise, does it take to do a good job of all that testing to spool up into a new refrigerant? Obviously, this time we really haven't had to change oils, so I imagine that probably helped a little bit.
Well, and the other thing, too, is because we are dealing, A2L was a new classification that was established by ASHRAE, which means mildly flammable. And so the concern about flame propagation, the amount of burning velocity, those tests had to be conducted as well. And of course, then you get the safety agencies involved to understand what rules do we want to place around these refrigerants, knowing that we have different applications, different types of equipment for those applications, and different charges of refrigerants. So the whole concern about safety has taken really years to vet out how we wanted to deploy these new refrigerants, that the benefit of them is much lower global warming potential than a lot of the existing refrigerants that we have.
You mentioned classification, a new classification as A2L was when it came out. And we're in the US, North America, we're really just now seeing them finally deployed into the field, at least in the stationary market. We've had them for a while out there in the mobile market with 1234YF. What was that classification and why did it come about?
If you go to the ASHRAE, ASHRAE classification chart of refrigerants. On the left-hand side, you have flammability, and on the right-hand side, or the horizontal axis, you have toxicity. So most of the refrigerants that are out there, either on the air conditioning side or the refrigeration side, were classified as an A1, meaning that there's no flame propagation and they're low in toxicity. The A2L refrigerants are low in toxicity, but they have some degree of flammability to them. So that's where that new category A2L came into play. Now, we also have been introduced with, at least on the commercial refrigeration side first, and it's also being used in air conditioning and was used a long time ago, a refrigerant called R290, which is commercial grade propane. Take the propane that you have in your barbecue grill, continue to condense out any of those solids, and then you have what we call refrigerant grade propane, which is a very good refrigerant. It's got basically the same pressure enthalpy curve as R22. So in terms of efficiency and capacity, it's a great refrigerant, but guess what? It's classified as an A3, meaning that it's very, very low in toxicity, but it's highly flammable.
That doesn't have an odorant in it because
That's one of the non-condensables, right?
Yeah, one of the non-condensables in there, so it doesn't boil and condense at the same time as the refrigerant. So if that leaks out, then we don't have that smell like we get out of a barbecue tank or a tank of propane sitting outside somebody's house.
So the rules that are in place for R290 or propane in terms of safety are around limiting the charge. So even if the entire charge would leak out of the system, you're not building up enough concentration of the refrigerant to be a concern.
So do we have anything similar to that requirement with the A2L refrigerants, which we're using primarily R454B and R32, correct?
Yeah, so on the air conditioning side, we have R454B, which will replace R410A. In Europe and Asia, mainly R32, which was a refrigerant that was developed and patented by Daikin.
Okay, now when you say replace, does that mean that it can go into an existing system?
No, let's make that distinction here. Because it is mildly flammable, it's not a replacement for existing systems. What I mean by replacements is that new equipment that is being designed to utilize that refrigerant for the purpose of air conditioning, that's what I mean by replacement.
Okay, yeah.
It's a good, what we call a medium temperature refrigerant. For the most part, we're going to condition spaces between 68 and 70 something degrees Fahrenheit. We're going to condition those spaces. So it's a good medium temperature refrigerant. So that's on the air conditioning side as R454B and R32. On the commercial refrigeration side, now we have some other refrigerants, because we have to keep in mind that in some cases we need to condition spaces below freezing temperatures. So now we have our 454B R4A, we have R454C, and we have R455A. So those are the three primary refrigerants, or A2L refrigerants, that are going to be much lower in GWP than either R448A, R449A, or even 404A, which is the predominant refrigerant. Now, if you go to supermarkets, then R407A and R407F come into play.
Gotcha. So we're going to see those. And again, the same thing there, I'm guessing, is that those refrigerants are going to have to go into new equipment. They're not going to be able to be retrofitted into existing equipment.
That's absolutely correct. Yeah, you cannot evacuate R448A, for instance, and then recharge the system with one of the A2Ls. It's not compatible, and it's dangerous because you have to basically remove any source of ignition because of the mild flammability.
That's what I was going to get into here. Let's talk about why that is. You're talking about sources of ignition. What do we consider sources of ignition in that case?
It goes the gambit. Anything that either has a set of contacts in it, that has the ability to spark, or that can generate excessively high temperatures, that could be a source of ignition. So when you think about kind of the simple things, relays that are in controls, contactors, any type of switch gear that you have, electric motors. We've seen older motors, when you turn them on, you can actually shut the lights off and you can see sparks. You can't use those type of motors anymore. So anything that would be a potential source of ignition for the refrigerant, if it were to leak out of the system, basically you either have to prevent it from the refrigerant from actually getting to that source of ignition, or you have to eliminate the source of ignition completely.
And does that really apply to things as they're operating normally, or does that also apply to things if they go into a failure state, like, say, a motor overheating or a relay overheating or something like that?
Yeah, it would be, we're getting a little bit on the technical side, but what we dealt with this with R290 because of the high flammability. So Europe has slightly different standards than we have in terms of safety protocol, but for the most part, they're similar. One of the primary safety agencies, UL, they actually, to simplify this for A2L and A3 refrigerants, they created two categories for component manufacturers like ourselves for A2L and A3 refrigerants. If, again, without getting too deep on this, so you have what's called LZGH2/8, outlines all the requirements for basically not having a source of ignition. And that's down to the opening size of maybe a vent hole on a control or a motor that could be a pathway for A2L refrigerant to reach that source of ignition. So when you asked earlier, okay, is that in the operating state and the non-operating state? The answer is yes. And that's because once the system shuts down because there's a leak there, then you still have to worry about hot surfaces or sources of ignition related to that. Now, the other piece that got layered into these requirements is leak detection. And again, this is a little bit complex. The leak detection, there are some calculations that a manufacturer of equipment would have to go through to determine how much charge of refrigerant is in their piece of equipment, and then what is the room or the area that they're conditioning. And there's a calculation that you go through to determine if if you are above a certain limit in terms of that refrigerant charge based on the room size that you're conditioning or the environment that you're conditioning. You may have to also add leak sensors and then a controller that can act as what we call a mitigation device. What is that? That means that the refrigerant reaches a certain concentration, what we refer to as LFL or lower flammability limit, then that sensor is going to have a built-in trip point that cannot be changed, and it's calibrated based on the specific A2L refrigerant. And that's because we want to make sure that that sensor, that refrigerant sensor, is the highest level of accuracy that it can be. And then there's, again, some other requirements that are built into that, meaning that that sensor has to be self-diagnostic, checking to make sure that it's operating properly. So it has some smarts built into it. In the particular sensor that we're using, we're not only checking to make sure that the sensor itself is working properly, but also baselined against temperature and humidity, because the technology that we're using in our sensors can change slightly based on temperature and humidity. So to make sure it's accurate, we check against those two baselines, if you would. Those are a summary of the requirements are. One is you have to either keep A2L refrigerant from getting to a source of ignition by sealing up enclosures and so forth, relays, contacts, or you have to eliminate those. And then if you're over a certain charge limit based on the room size you're conditioning, then you will have to bring in leak sensors and mitigation. The mitigation protocol is very specific. It's tied to UL's two standards, which are under what we call 60335 2-40 is for air conditioning equipment, and 2-89 is for commercial refrigeration equipment. So these are long standards. Lots of it are, unless you really talk to somebody and try to understand them, they're very complex standards. So it helps to have folks that are familiar with the standards and can summarize what are the critical points on these standards. So those are the two, again, elements that are there: leak detection and eliminating sources of ignition.
Gotcha. And those are, I would say, pretty big changes to equipment that we're seeing coming out here with the A2Ls in them. And hopefully people have been learning enough to put this stuff in correctly. There's been a lot of education out there on it. I know all the manufacturers and a lot of distributors have just been really working hard to get everybody educated about what they're going to have to do here.
Yeah, it's something that you just can't read one document and you're up to speed, because it is a change in what we're used to in the HVACR industry.
So I'm curious as to why you talked about R290 a little bit and mentioned, hey, that's a really great refrigerant. A few of us have been around long enough to work with R22 some, and I love that. It was a great refrigerant, but we moved on. Why were the A2Ls selected over going to something like R290? Because R290 has an even lower global warming potential, right?
Yeah, it really comes down to two things. One is safety, and two is cost. So you can have multiple circuits using R290. I guess the third would be just general equipment size, physically being able to put compressors, evaporators, condensers, piping, and so forth into a system. Basically, the first thing is you run out of cooling capacity, because if you're limited by charge, the refrigerant charge, there's only so much capacity, cooling capacity. So for instance, on let's say a two-door freezer, low temperature freezer, reach-in freezer, that's about somewhere around 2 horsepower, maybe 3 horsepower is about the largest cooling capacity that you're going to get. Well, think about it. If you have any case that's larger than that, or a walk-in cooler that takes more cooling capacity, you can't get there with the charge limitations. Even though the charge limitations on R290 were increased over the last year through SNAP Rule 26, which was issued by the US EPA, you still can't get there from the amount of refrigerant that you're limited by. So that's where the A2Ls came into play. So what I like to say is on smaller capacity systems, at least on commercial refrigeration, R290 is a great refrigerant. But once you get over, let's say, 2 to 3 horsepower in cooling capacity, now what are you going to use? Those systems are too, at the current time, they're too small to be used to apply CO2, and they're too large to use R290. So you have this cooling capacity range that sits in the middle of your equipment, offering that you have to have a refrigerant that you can utilize for this cooling range. And the best refrigerants that are out there now are the A2L refrigerants. And the same thing is the case to some degree is on air conditioning. You can use R290, they're used all the time in window air conditioners. But when you get up into centralized air conditioners, there's really not enough cooling capacity there.
Yeah, because we see a lot of R2, well, not 290, but like 600 and 600A now in residential fridges and freezers.
Sure. Isobutane is R600A. So that's another comparison. The other thing that comes into play is the cost, the performance of the compressor based on the refrigerant's what we call sweat volume. Once you get above a certain cooling capacity, R600A is no longer as efficient as if you would go to R290. So you're going to use less energy and get more cooling capacity as you go up in cooling capacity with R290 than R600A. R600A is smaller residential refrigerators, dorm size refrigerators, countertop refrigerators. That's where R600A comes into play.
Yeah, a lot of changes out there that we're seeing, and it's hard to keep up with all this stuff. And that's why I'm glad we have people like you to come tell us.
Yeah. And then when you talk about installation and servicing, again, you have to think I'm dealing with a mildly flammable refrigerant. What do I need to do here to be safe? You shouldn't bring a torch in and start brazing or soldering or welding piping. The first thing that needs to happen is you purge the system with nitrogen, you evacuate the refrigerant. And this is if there's a leak, right? If you know that there's a leak, you're going to have to perform leak tests, pressure tests, and make sure that once you do fill that system with an A2L or a mildly flammable refrigerant, that you have a sealed system.
How hard are these A2Ls to ignite, realistically?
They're mildly flammable, so they take a little bit of work to get them to unite. And that's why if you look at, we keep referring to the LFL level, which means lower flammability limit, we're basically have a 4 times safety factor with the leak detection that goes in. So it triggers at a 25% LFL, and immediately then you start to go into what's called mitigation, which means that you typically will turn off the compressor, turn on your evaporator fans to disperse that refrigerant. Anything you can do basically to get that concentration of refrigerant that's leaking below that 25% LFL level. In some cases on larger equipment, you're going to have isolation valves. So you're going to prevent any additional refrigerant once you know that there's a leak from leaking out of that system and contain it within the piping or some type of vessel, if you would.
So a lot more changes on larger systems then too. And that probably goes into the essentially cubic footage calculations of the structure that it's feeding.
Yes, the amount of charge and how much exposure of that refrigerant do we have with a space that people occupy.
Yeah, so that would be something like a large VRF system or VRV system where it could dump a ton of refrigerant into one tiny office or one tiny area that has a small head unit in it. Probably going to want to put some isolation valves on that some way to stop that 80 or 100 pounds or whatever's in that system from coming in there.
I mean, as a general rule, anything that would be considered a split system, right, where you have a remote condenser is probably going to need leak detection and mitigation.
Pretty much anything then.
And then the question is, okay, how many leak sensors do I need? Again, 60335 defines what the response time is. And that's really around if the system is going to leak, where would it typically leak? So maybe on a small evaporator coil that's no wider than 4 foot, you may be able to get away with one A2L refrigerant sensor. But anything that's going to be wider than that, the refrigerant's typically going to leak on one of the end bends that's brazed in. Vibration over time, temperature changes, you may develop a leak. Smaller systems, refrigerator, freezers, typically you don't see leaks in those because it's one continuous piping run and very few joints in those type of systems. And they don't get moved around a lot, and they've done a great job with isolating the vibration. So you don't really see a lot of leaks, but these larger systems, right, where you have access valves and different brakes, what I would say brakes or braze joints in them, that's why we have now the requirement with these A2Ls for leak detection and mitigation. So again, back to the original discussion, as the coils get wider, you may need 2 sensors, but you have to conduct testing. The manufacturers will have to conduct testing and actually simulate leaks and prove that they can actually get below that 25%, at or below that 25% lower flammability limit within the defined time period.
Interesting. So they're really going after, we're trying to make these as safe as possible for the occupants, for the structures, for everybody involved, because we don't need any more fires in the world. I think we've had enough this year already.
Yeah, for sure. Yeah, and these are smart systems. I mean, they, again, whoever put these standards together really thought through them. Let's say you have a system and you have 2 sensors that are there. You've determined that I need 2 sensors to meet that standard. If a service technician unplugs one, the controller is not going to let that system start up because they know they're missing a sensor. Likewise, if the system is designed for use with R454B and somebody, for whatever reason, the sensor failed and they put a new sensor in, but it's not calibrated specifically for R454B, they may have an R32 sensor on their truck. They plug that in. The controllers are smart enough to know, no, I'm not seeing that handshake with this sensor that says this was calibrated for R454B. So I'm going to not allow you to start the system up.
So the controls are then, or the sensors are specific to the refrigerant that's in the system.
They are. They're calibrated specifically to each A2L refrigerant.
Interesting.
And that's because each one of these refrigerants has a different molecular structure. And so to make the leak sensing accurate, they're calibrated for those different chemical compositions.
So that's definitely something people are going to have to pay attention to on servicing, because I'm sure that at some point these sensors are going to fail sometime. We make mechanical objects and they all do.
And think about it too, that a faulty sensor from a system standpoint is the same as a leak being detected.
So it's going to shut that system down.
So the first thing is going to shut that system down. For safety purposes, it's going to shut that system down. So technicians that are going to be servicing A2L equipment, they need to be knowledgeable about what we just talked about the sensors, and they need to be knowledgeable about, in general, the actions of the controller.
Does that controller delineate when it puts out an alarm, or does it put out a different alarm if the sensor has failed versus if the sensor is sensing a leak?
Great question. Very good question. There's 2 types of A2L sensors in terms of output signal. You can have an A2L sensor that's just a relay output, or you can have one that actually has a Modbus communication output. With either one, you don't know if it's a fault versus a refrigerant leak, with the exception that if you do look at the Modbus register, it will actually tell you what the highest LFL level is for any of the sensors connected to that controller. So let me retrench on that answer. You would know with Modbus, you would know if it's a fault versus a leak, because with a fault, it wouldn't show you that LFL level. I think a lot of the residential systems that are out there are fairly simplistic when it comes to leak detection, and they may just have a relay output. So you'll know that you either had a refrigerant leak or you have a faulty sensor. The third could be, which goes in that faulty sensor area, it could be the sensor has gone end of life, because the sensors do have built into them kind of a lifespan.
Is this an electrochemical sensor then, or?
Different technologies that are out there. I would say the bulk of them that are out there right now are what we call NDIR, non-dispersed infrared. That technology's been out there for a long 30, 40 or more years, very accurate, very responsive type. And the newer technology that's out there is speed of sound, where as the refrigerant gets entrained in a cavity in the sensor, it changes the dynamics of a sound wave. And based on how those sound waves change, the algorithms that are in the microprocessor know what the LFL level is of the refrigerant. So while that technology hasn't been out there as long, it is super fast. Within 9 seconds or less, you're going to know whether or not you've got a concentration of refrigerant that's above that level.
Very cool. I wasn't aware of the speed of sound sensors. That's a neat technology, it sounds like. I'm a little curious, being a former technician myself, how are we going to troubleshoot these sensors in the field?
Yeah, so Modbus is going to be service technician friendly, because it's similar to, well, I'll just Google it. Well, that's exactly what it's doing, because with Modbus, you have all the information that the sensor's seeing is available to the service technician. So what will the service technician know? Again, if there's several sensors, Modbus communication is going to tell that service technician, hey, it was sensor number 1 that actually registered the highest concentration of A2L refrigerant. So in terms of servicing, you're going to focus on that sensor that picked up the highest LFL level. The same thing with a faulty sensor or a sensor that's gone end of life. A sensor that's gone end of life with Modbus, you can actually warn the service technician and or the building owner, hey, 90 days from when it's going to go end of life, you need to change this sensor out. So that's where, again, having these smart sensors tied to a controller that can communicate. And then if you take that one step further, the solution that we have available, you have the option of connecting that controller to a cloud platform. So if you want an SMS text message or you want an email, whenever you have a warning or an alert, it's going to be instantaneous of you knowing you have a refrigerant leak in that system. So that's what the world is going to, right? Is a connected type of devices. It won't be in all these systems, but HVACR systems are getting smarter and smarter, mainly to improve efficiency and provide a higher level of equipment uptime.
So what about the sensors where they're just a relay sensor? How are we going to test those? Because
a relay, you'd have to look at each sensor because you don't know. It serves the basic purpose of knowing that either it picked up a leak or there was a fault. So it serves that purpose in safety reasons, but it's not intelligent enough to give the service technician that level of information that I talked about earlier with Modbus.
Interesting. Well, that sounds like it's going to be a big challenge for the industry to overcome as they come through this, especially with regards to servicing. And that's probably going to be a lot on the residential side. And I'm going to guess a lot of the smaller systems are going to see those type of relay sensors that aren't going to have the full Modbus communication to get the information back out of them.
Yeah, and just because a sensor, the other thing I'll mention here, Eric, is that even though a sensor may look physically alike, again, back to check to make sure what that sensor is calibrated for, check to make sure what the input voltage is that's required, because some of these are working off of 5 volts DC. Ours is working off of 24 volts. It can be either AC or DC. So you have to make sure that the supply voltage is correct as well.
A lot of things to think about when we're going to go replace a sensor out there in the field. Definitely a lot of things that I hadn't thought about. I've been out of the field now for a little while and I haven't had to work on any of these yet. So you're opening my eyes here.
When you get to Modbus now, what is the baud rate that the sensor's communicating to the controller? Again, it's not one size fits all when it comes to the sensors, whether they're relay or Modbus type sensors.
Let's switch gears here a little bit. I wanted to ask about what you see as the effect of all these equipment changes to like homeowners and building owners and the buildings that they're in.
For residential, homeowners really won't see any change in performance, so to speak. As long as I'm comfortable, my house is warm, my house is cooled to what level, homeowners really aren't going to see anything different. There will be some costs. Somebody's got to pay for all this technology, especially when you introduce leak sensors and mitigation. So there will be some cost increases. How much? I don't really know. That's really a question for the equipment manufacturers. On the commercial side, it's going to, the A2L refrigerants, because they are mildly flammable, there are some changes that are being made to the building codes. So ASHRAE has a great interactive map where you can go in and click on any state, and now you can click on any province also in Canada and see where these different states and provinces are in terms of updating their building codes. So that's the last piece here. A lot of them, AHRI has done a great job working with these different states to understand where they are in their legislative process to get this moved along, but you can see where they are. There are probably the primary changes, again, in commercial buildings when you utilize A2L refrigerants is the enclosures, the shaft enclosures around the A2L refrigerant pipes, and then also what we call shaft ventilation around, because you've got to have some way of getting that refrigerant into the building, into the equipment. And right now, because they were A1, non-toxic, non-flammable, or low toxicity, low flammability, the building codes didn't worry about that. But now that we have A2L refrigerants, you have to think about fire.
Yeah, because we don't need more fuel on those fires. Again, we've had enough fires for the year already.
And then the last piece I talked about quite a bit was the refrigerant detectors. Those are the 3 pieces that come into play on commercial buildings.
Well, this has been educational. Really glad we got you to come on. Keith, any last thoughts for our audience out there today?
We're moving closer to being to a point where the global warming potential of these refrigerants is at an acceptable level. I'm sure that our government, as well as equipment manufacturers and refrigerant producers, are going to continue to look at improving efficiency, which lowers carbon footprint. They're going to look at what else they can be done with these refrigerants so that they maintain their capacity, cooling capacity, maybe improve their cooling capacity, improve their efficiency with actually lowering that lower GWP level. So I don't think we're done yet. I mentioned just briefly CO2. CO2 is a great refrigerant, but I think we're going to continue to see technology improvements in heat exchangers and equipment where CO2 can be a viable source coming down for smaller systems and capacity. Stay tuned. There's more to come, but manufacturers, again, and governments across the globe, they're concerned about the environment. They're concerned about what impact global warming is having on the environment in general. So you're going to continue to see this research and development around all the elements that I talked about earlier.
Interesting. So it sounds like we're not done changing yet, but
I don't think so.
Yeah, one thing about this industry is if you don't understand what's going on today, you better learn today because it's going to change tomorrow.
Yeah. And let's face it, I mean, for the longest run, we had a very limited number of refrigerants. Naively, we didn't know that they were causing as much harm as they are to the environment. So that's why we're seeing this plethora of refrigerants, these A2Ls, CO2 now, R290 made its reappearance because of the fact that these are much more environmentally friendly refrigerants.
Well, very interesting. Keith, I want to thank you for coming on. Thanks to Penn Controls for allowing you to come on here and talk about this today. It's been a whole bunch of fun and educational. I hope it was educational for everyone that listens to it. I sure learned a lot. So thank you. Really appreciate it.
Yeah, you're welcome.
Thanks for joining us here at Building HVAC Science. If you have any questions or want to suggest a topic, you can reach out to us at marketing@TruTechTools.com, TruTechTools.com. Some of the topics we discuss require technical training for proper interpretation or safe execution. So if you're trained pro, you can proceed, but if not, please consult with and hire a pro. The Building HVAC Science podcast is a production of TruTech Tools Limited. In full disclosure, I'm the owner of TruTech. The opinions expressed are those of my guests, my co-host, and myself, depending on who is speaking, of course. And if you're in the market for any tools or test instruments mentioned in our podcast or otherwise, you can take a look at TruTechTools.com. That's TruTechTools.com. And you can also use the offer code of HVACBS for a nice discount. I want to thank you for listening to this podcast today, and hopefully you're following us on Building HVAC Science. We have a lot of great partners in the industry, other podcasts and resources and influencers. I'll cover a short list here: AC Service Tech, Measure Quick, HVACX, The Misfits of HVAC, HVACR School, HVAC Shop Talk, Stephen Reardon, HVAC Reefer Guy, Tool Pros, Service Business Mastery, Quality HVAC, HVAC Overtime, HVACR Videos, the HVAC Grapevine, and HomeDiagnosis.tv. Again, thank you for listening. We hope you got something out of the content today, and you come back again to listen to more about Building HVAC Science. Take care.